Alright, hey everyone. So this is going to be question number 8 on the discussion, and it's going to be find paths. And so what find paths is going to do, as they mentioned before, is pretty in this like text right here. It's pretty similar to discussion number 5, find paths, but with like a set where we have like a data abstraction with like a lowercase t, and now we have like actual tree objects. So a t, you see like the capital tree right here. And so what find paths is going to do, it's going to return a list of paths, and these paths are represented as lists. So like a list of lists containing nodes along each path from the root node to like an entry, and we're going to define that entry as like a parameter. So in case of find paths, entry might be like 5. That's like the node that we're looking for. We're trying to find the path to that node, and you can return the paths in any order. And so in the case of the tree on the very left, so I'll change this up. This doc test is going to look like this. The paths look like this. So there's a path from 215 to 765. So a resulting value is going to be like list of paths of 215. So like first node, second node, and end node. And by the way, we're searching for the target node, entry being the number 5, this doc test right here. And along with that, another path that we have is 2765, representing like this path down here. And so we got all of that down. Let me exit through all of that. And now I want to present like a different doc test. And so I think this might be a bit more useful for getting to know how to solve the problem. And so what if we also had a 5 right here? Well, there are like 3 different paths now, right? So there's like 215, so that's a path right here, 215, and another path is 25, because we reached one node, the 5 right here. Along with that, we also have the path 2565. And so there are 3 different paths, and like, we have like a path that has like 2 5s along the way. And that's fine because we're just trying to find the path to like any single 5 in the tree. So our path can also have 5s along the way. It just has to end in a like unique 5. And so yeah, keeping this in mind, let's get started on how to solve the problem. And so keeping in mind, once again, it's like a tree data structure. We want to do things like recursively over the branches. And so we're going to make like recursive call on this branch, recursive call on that branch. And every time you like find yourself like stuck on a tree recursion problem, just think about, what are my recursive, like make a good example of like a tree. You can even use like the doc test example. So for example, this tree right here. And you can go like, if I made a recursive call on this left branch, what would the tree look like? What would the result look like? And if I made a recursive call on the right branch, what would that look like? And so what we can do is let's make a recursive call on this branch first. And so if we make a recursive call on this branch first, what is our what's the result? Well, we want a path to this 5, and we want a path to that 5. And so because of that, the resulting path is going to be, first is the path to like the very top, so like the 5 right there. And we notice, we're already at that path, so we're going to return. So one path is going to be a list with just the element 5, because you only have to take one node to like reach that 5. And along with that, we also have the path 565, and so that's going to be another element in our list, 565. So that's going to be a recursive call number 1, and let's go to like recursive call number 2. And so in the case of this one, we call find paths on this sub-branch, and we're looking for the number 5 again, and we notice there's only one path, 1 to 5, and so our resulting value is going to be 1, 5. And yeah, so we got our recursive calls down, and now we need to think about how do we combine these values to get our result, like 215, 25, and 2565. So like the paths of the entire tree. And so if you think about it, what's going to happen is that, let's see, 565. Where does that fit into like the corresponding result? It fits in right here. Whereas the 5 fit in, it fits in right here, and the 1, 5, it also fits in right here. And what's the pattern between all of these? Well, we know that each path in the branch is going to designate, like for example, the 5 is going to designate the path to like the first 5, 5, 6, 5 is going to designate the path to like the path right, the 5 right there, and the 1, 5 is going to designate the path to the 5 right there. Well, to combine it all together, what we want to do is we want to add the label to on top of it, because like, you know, we have the path 1. Man, this is getting super messy, but imagine we have the path like 1, 5 right here, and to get like the total path of the entire tree to that 5, what we want to do is we want to add the 2 on top of it. So 2 goes to 1 goes to 5, and you can imagine right here we have like 5, 6, 5, and we want to go like 2, 5, 6, 5. That's the entire path. And so what we're doing is we're taking a recursive call to every single branch, and for each recursive call we're going to get a list of paths of that branch, and what we can do is we can add the current label that we're at, in this case the 2, and adding the 2 on top of that will get us like the entire path from like the root node to the branch and then to the 5 at the very end. And so we're going to take the path from each of them and add to it. And so we can start out with our code maybe. And so one thing we want to note is that we have an if statement at the very beginning, paths variable, that's like an empty list. And so judging from that, we can determine that like, you know, paths is the variable named paths, so it's probably going to represent a list of all the paths that we have in our result. And you know, the return value of find paths is going to be a list of all the paths, so we probably want to return paths at the very end. So return paths, list of paths. So paths is going to be a list of paths, and yeah, so I'm going to zoom in a little bit. And so we have an if condition right here, and we can maybe like skip that for right now, but we see that we have a for loop right here. And you know, what do we know with like for loops and trees? It's probably going to be a for b and like iterating through all the branches. And so it's going to be for b in t.branches. And you know, what do we want to do with each of the branches? We want to make a recursive calls, and then for each of the elements of that recursive call, we want to add the label, and we want to add like that new path to like the list of paths right here. And so the question is, you know, what's this line right here? Because we have a colon and we have like an indent. So it's going to be like an if statement, a while statement, a for statement. And thinking about that, like what could it be? And so going back to like the drawing board right here, we know that we're going to have like a list of different paths. Yeah, maybe this is just an example. It's not necessarily right. I'll make it right actually. 5, 6, 5. And you know, we want to add for each of the labels, for each of the paths, we want to add 2 to it. So like imagine like 2 plus the list 5 and like 2 plus 5, 6, 5. And that means we're going like for each of the elements of the recursive call, we want to do something with it. And because of that, we have to iterate through the recursive call. And so we have to get each individual path and add it to like the total list of paths right here. And so keeping that in mind, we probably want another for loop in here. So we're going to be for maybe a branch path in the recursive call. So find paths of that branch, and we're looking for that same entry value. We want to take each of the elements. So in this case, it might be like the list 5, and we want to add 2 to the beginning. And we want to add that to the entire list of paths. And so that's probably going to look like paths.append of that branch path. And remember that we want to add the current label on top of it. And so that's going to be t.label plus branch path. So we're adding the 2 to the path of the branch. And so yeah, we got that down. And now we have one more thing left to take care of. And that's going to be an if statement right there. And so the question is, how do we get the path in the first place? How do we like find something to start off of? Well, if we notice with our tree up here, let's say we're making a recursive call on like the 5, 3, 6, 5, 11. And you know, we expect the 5, 5, 6, 5 out of it. And the question is, recursive call on this 3 branch is going to get us an empty list. Oh, it's cutting into the cam, so I'll move it over a little bit. So we're expecting like the 5, those 2 paths, and then what's going to happen is that the recursive call in this branch is going to get an empty list, and the recursive call in this one is going to get like the list 6, 5. And so the question is, where do we get this 5 path from? Because we know that 6, 5 corresponds to right here, and the 5 path is going to correspond to, it doesn't correspond to anything. It didn't come from either the recursive calls. And so that means that what we want to do is that once we found the entry value inside of our current node, we want to initialize like a path. So once we find the 5, we want to start a path and then saying like we're starting at the node 5, and we're going to go back up and like accumulate off of that. So if you might imagine, like right here, we saw the value 5. So we're going to start an empty list 5, and it's going to accumulate the 6 on top of it, 6 plus 5, and we're going to add like the under 5 on top of it. And so that's what we're going to do in this if statement. And so what's going to happen is we're going to go if t.label is equal to the entry. So if it's equal to the entry, then what do we want to do? We want to add another path to our list of paths. And so we're going to do is do paths.append of a new path with only the element t.label. And so what's going to happen is that, we're going to start off with like some label 5. So like right here, it's going to return 5. And we're going to accumulate the 6. We're going to accumulate the 5 on top of it, and it's going to build up backwards. And if we run this in the code, let's see. Hopefully this works. And yeah, so it happens to work. And so just to reiterate over like what's happening here, we're starting out with like a list of paths, and we're going to add on each path as we go through like the program. And if we see that the current label that we're at is equal to like the entry, so like the value that we're looking for, we're going to add a new path, and that's going to be like t.label, just the element t.label, because since we're already at like the very top, we're already at the entry, our path is going to be a list of length 1 with like t.label. And then we're going to go through each of the branches and get the paths to each like node, get like a list of paths to like whatever like value that we want. We wanted the path to entry, and for each of those paths, we're going to add on like the current value that we're at to like complete our path in that tree. So in the case of like the tree like 1, 5, this recursive call is going to get like the list of one path with the element 5, and then to get our actual path, we're going to take like the 1 and add it in. It's like the 1, 5, like we're adding a 1 into here for each path that there is. And then at the end, we got all the paths that we want, so we're going to return paths, which is the entire list of paths. And yeah, that's going to be the function find paths. Kind of complicated, but once again, if you ever have any questions, feel free to like ask me or email me. And yeah, have a great day.